Good afternoon, ladies and gentlemen. My name is Siriphaka Namanakita.
My name is Chera Pampala.
So today we would like to present our project called Oil Absorbent Booms from Popcorn-derived Porous Carbon Flakes. Before we start talking about popcorn carbon booms, you must know the theoretical background. This is the picture of normal booms that nowadays people use. Most of them are used to combine oil to block dispersion, which it made from floating material, for example, foam like wood or plastic. The popcorn has the similar feature with foam. It has a lot of porous, which is the main cause of oil absorption. Moreover, when it's burned, the porous continue to be more. Then carbon in popcorn is a property that helps absorption oil. Objective: first, stopping water pollution in the community's water source. Second, testing efficiency of popcorn's absorption. Hypothesis of study: porous inside popcorn carbon affect oil absorption. Popcorn carbon can absorb oil more than other types of carbon. Shape of booms affect popcorn's absorption. And the last one, popcorn carbon booms can utilize as a fuel in the household.
Next, we will talk about prepare experiment. The first one, how to make popcorn. We put oil in pot on a medium-high heat and put 125 grams of kernels into it. Let the kernels pop and shake the pot once the popping slows to several seconds between pop, and remove the pot and then weigh popcorn. The second, how to make popcorn carbon. After we have popcorn, we put it on the burning tray and burn it for 3 minutes. Then weigh it and bake in the 100 degrees Celsius for 45 minutes to remove moisture. The third, how to make crushed carbon. Burn carbon until it gets carbon and guide it. Put carbon crush, make charcoal. Briquette and mix carbon, water, tapioca flavors in 10-10-1 and put the mixture on mold. Then bake it in 100 degrees for 2 hours. Next is experiment. We have 7 sections of experiment. The section 1, time record to make popcorn carbon. Independent variable is time record to make popcorn carbon 3 times. Dependent variable is the amount of carbon obtained. Control variable is 120 grams of popcorn carbon. Test method. After we burn popcorn, refill the popcorn from another and then weigh them all separately and repeat the method, but change the time record to 3 and 5 minutes. This is the table of record to make popcorn carbon. From table, we can see that 3 minutes is the best time for burning popcorn to carbon because it's burned completely and has no cinder left. Section 2. Comparison of porous with 2 of carbon. We take coconut shell, charcoal, and guide it into the flake, then view through microscope with using multiply by 100 and do it again with popcorn carbon too. Then comparison of porous with 2 of carbon. This is the picture inside of carbon flakes. We can see that porous of popcorn carbon flakes is more than porous of coconut shell carbon flakes and also smaller, so it means that popcorn carbon can be effectively oil absorbent. Section 3. Comparison of oil absorption with 2 types of carbon. Independent variable is popcorn carbon flake with nylon net, popcorn carbon crush, coconut carbon shell flake with nylon net, and carbon coconut shell crush. Dependent variable is the amount of oil absorption, and controlled variable is time, the amount of oil, diameter of capacitance. Test method. We pack popcorn in nylon net, then weigh it before absorbing oil and put 150 milliliters of engine oil in 200 milliliters beaker. Put wrapped popcorn carbon into a beaker for 5 minutes. After 5 minutes, we weigh it after absorption and then repeat all methods but change the crush popcorn carbon, coconut shell carbon flakes, and crushed carbon shells. This is table of oil absorption with two types of carbon. From the experiment results, the carbon from coconut shell flakes is the most oil absorbent with 11.5 grams of oil carbon. Flakes is better because it was in the second place of oil absorption and can float.
Section 4. Comparison of oil absorption with two types of carbon in the water. Independent variable are popcorn carbon flakes, coconut shell carbon flakes. Dependent variable is the amount of oil absorption. Control variable are time, the amount of oil, diameter of capacitance. Test method. Pack the coconut shell carbon in a nylon net, then put 150 milliliters of water in the beaker, and then drop 10 milliliters of oil. Wait it before absorbing oil and put into the beaker for 5 minutes. And wait after absorbing oil. Then repeat the methods, changing to the others carbons. From the experimental result table shows that a wrapped carbon popcorn flakes has the lowest total weight, so it has the ability to float on the water. Also, it can absorb the most compared with others. Section 5. Comparison oil absorption in time. Record of oil absorption between fibers and carbon popcorn in the water. Independent variable are popcorn carbon flakes, coconut coders, and cattail fibers. Dependent variable, the amount of oil absorption in time. Controlled variable are the amount of water, the amount of oil, and diameter of capacitance. Test method. Pack cattail fiber in nylon net, then put 150 milliliters of water in the beaker, and then drop 10 milliliters of oil. Wet it before absorbing oil, then put into the beaker and record time. When it completely absorbed, fill more oil, about 20 milliliters. After that, fill more oil, 30 milliliters, then wet it until it cannot be able to absorb. And then repeat the methods, but changing to popcorn carbon flakes and coconut coders. From the table, show that wrapped cattail fibers is the lowest weight of oil absorbent and also take the least time of absorption. Moreover, it can absorb time amount of oil more than others. Section 6. Comparison of boom shapes. Independent variable is shape of boom. Dependent variable is ability to absorption for each shape. Control variable is the amount of carbon popcorn used container and the amount of oil. Test method. Use 10 grams of popcorn, then decide the round shape and make nylon net to be a round. And then put 30 milliliters of iodine on beaker and put popcorn carbon and record the time. The timetable shows that the round shape has the best absorbency because it has a lot of texture. Section 7. The full test. Bake the popcorn carbon boost model at 50 degrees Celsius for 2 hours. Leave until fully dry and burn the model and take the timer to observe the burning, and then repeat the methods and changing to other models. From the experimental, coconut coders have highly burnable and have the longest time of burning. Discussion and conclusion. Normally, oil booms made from the floating material, for example, foam, light wood, plastic, and so on. Once popcorn is burnt until become carbon, it looks like foam, which inflates on water. Aside from popcorn carbon flakes floating from the second experiment, can see that inside of it has more porous, which help in the oil absorbent efficiently and have lower weight than coconut shell carbon flake. Even if in round, popcorn carbon still float on the water, but coconut shell carbon cannot. Although cattle fibers can easily absorb oil in the water and faster than others, but it also easily spreads. So wrapped carbon popcorn flakes can enhance absorption, especially in round shape, which has a lot of surface area. Moreover, oil absorbent from popcorn can burnable as well. Therefore, popcorn carbon can be one of the great optional for main booms.